Okay, rounding off activities to date with this BSA A65 Spitfire engine project. We've got the crankshaft all back together and ready to go with its super duper new conrods and new big end shells, sludge trap cleaned out. Time inside main journal is okay, well it's very good actually, as are the big end journals. The time inside bush is good as well, so I'm leaving that alone. It's very good. We've also got this matter. Now there's been some strange things going on at some time with this engine. We've got a ball bearing on the drive side which was superseded by a roller bearing in later years. But we've also got a number on the engine that would suggest that it's too high and too recent to have this type of bearing in it. So I was a little concerned about what we had here, and I've done a trial assembly of the crankcases and had the crankshaft in. I didn't video it, but the reason being I wanted to see what, if any, end float there might have been in the crank. Now obviously I know that when the crank is fitted to the ball bearing and the alternator and engine sprocket and everything fitted and a nut on the end done up, there won't be any. But I wanted to know how much potential end float there could be between the cases, because I've heard that there's different types and different widths of crank, and there's different widths of time inside bush as well. Now apparently we've got the early what's called wide flange type in there, which doesn't use a thrust washer outboard of it. It's also possible to see that we've got the gearbox complete and working again. That's all in there ready to go. One new gear fitted, a full set of new bearings. Anyway, I found that when I put the crank in the cases and clamped them together, I could raise around about 5 to 6 thousandths of an inch end float, which would have been taken up had I sort of fitted, as I said, all the gubbins outboard of this bearing and tightened the nut up. There wouldn't have been any, but I wanted to know how much the crank might be able to clatter around in the cases if it wasn't located firmly. And I would say that we're probably going to have about 5 thou clearance between this face on the crank and the corresponding face on the time inside bush when everything's put together and bolted together. The crank turned freely. The engine has obviously run like that before with no detrimental effects to the conrods or pistons, barrels or whatever. So basically I'm going to put it together and locate the crank firmly to the drive side, and then we'll have a trial fitting at some point down the way. When it comes to fitting the top end, I'll fit the pistons without rings, and I'll fit the barrels, and just make sure that the pistons, that the engine's able to turn freely without the pistons causing any binding or difficulties or whatever. Like I say, the engine's obviously ran like this before, and it wouldn't appear that there was a problem, although there is this has been welded. Now I've had to have one of these welded myself in the past. Probably, I think it featured in the relevant video about whichever engine it was within the last couple of years. So obviously something's happened here. I would say possibly someone's had a broken conrod. That's the usual culprit for doing that damage. So clearly this engine has been built up out of bits that don't necessarily correspond to the year of the original build, and whether somebody's stamped an engine number onto another blank case from a later engine just to keep things original, I don't know, in the paperwork, or keep the engine number matching the frame, whatever. I don't know what went on in the past with this thing. All I know is I'm pretty confident I can put it together with this ball bearing on the drive side and a really good unworn time inside bush and journal, and we should probably have a very good engine. But like I say, I'll just be careful and sort of monitor a few things as I go through the process of putting it all together. And if it turns freely by the time I've got it all bolted together and the crank in, barrels temporarily fitted, pistons without rings, and it all turns freely, I don't really see that there's going to be a problem. Also, whoever ran it last omitted, deliberately or otherwise, the little rotary breather disc off the end of the camshaft. Well, I've got one of those, so one of those will be going back in. I've checked and made sure all the oil ways are clear. I've had the oil pressure relief valve out and dismantled and checked and cleaned that. So everything we've got here is good to go, and hopefully the next stage will be a little bit more exciting, and all the prepping and cleaning and checking, and I might actually be starting to put something together to go back to being an engine once more. But that's where I'm leaving it for today.